The alternator consists of 10 parts: the drive, the slip ring and cover, the brush box assembly or pack, the rectifier, the suppression capacitor, the slip ring end bracket, the regulator, the brush set, the stator, and the rotor. The rotor consists of a field winding that is wound around an iron core and pressed on a shaft. At each end of the core is placed an iron claw to form magnetic poles. The consists of a laminated soft iron member attached rigidly to the casing that carries 3 sets of stator winding. The rectifier consists of diodes arranged to form a bridge network acting as a one-way valve so that the current generated in any winding will pass to the B+ terminal. The surge protection diode. This avalanche diode conducts when a surge voltage exceeds a given value. And finally, the regulator. This is installed to ensure the battery does not overcharge and to protect electrical equipment from excessive voltage. Catalytic converter is an exhaust emission control device which converts toxic chemicals in the exhaust of an internal combustion engine into less noxious substances. Inside a catalytic converter, a catalyst simulates a chemical reaction in which noxious byproducts of combustion are converted to less toxic substances by way of catalyzed chemical reactions. The specific reactions vary with the type of catalyst installed. Most present-day vehicles that run on gasoline are fitted with a three-way converter, so named because it converts the 3 main pollutants in automobile exhaust. An oxidizing reaction converts carbon monoxide and unburned hydrocarbons, and a reduction reaction converts oxides of nitrogen to produce carbon dioxide, nitrogen, and water. Internal combustion engine, E being our engine. The internal combustion engine is an engine in which the combustion of a fuel, normally a fossil fuel, occurs with an oxidizer in a combustion chamber. In an internal combustion engine, the expansion of the high temperature and high pressure gases produced by combustion apply direct force to some component of the engine. This force is applied typically to pistons, turbine blades, or a nozzle. This force moves the component over a distance, transforming chemical energy into useful mechanical energy. The first internal combustion engine was created by Etienne Lenoir. The internal combustion engine, or ICE, is quite different from external combustion engines, such as steam or Stirling engines, in which the energy is delivered to a working fluid not consisting of, mixed with, or contaminated by combustion products. Working fluids can be air, hot water, pressurized water, or even liquid sodium, heated in some kind of boiler. Radiators are used for cooling internal combustion engines, chiefly in automobiles but also in piston engine aircraft, railway locomotives, motorcycles, stationary generating plants, or any similar use of such an engine. To cool down the engine, a coolant is passed through the engine block where it is heated, is fed into the inlet tank of the radiator, which distributes the coolant across the radiator core, then cools down as it circulates through the radiator tubes to the opposite tank. The cold coolant is fed back to the engine, and the cycle repeats. This coolant is usually water-based with the addition of glycols to prevent freezing and other additives to limit corrosion, erosion, and cavitation, but may also be in oil. The first engine used thermosiphon to circulate the coolant. However, nowadays all engines but the smallest ones use a pump. As it circulates through the tubes, the coolant transfers its heat to the tubes, which, in turn, transfer the heat to the fins that are lodged between each row of tubes. The fins then release the heat to the ambient air. Fins are used to greatly increase the contact surface of the tubes to the air, thus increasing the exchange efficiency.